When we think about the most incredible birds on Earth, our minds usually jump straight to the apex predators, right? We picture a majestic eagle soaring over a canyon, or maybe a lightning-fast falcon diving for its prey. But what if I told you that nature's absolute ultimate champion is actually a slender, unassuming little bird waiting in coastal mudflats? Welcome to this explainer on the jaw-dropping reality of the bar-tailed Godwit. This is a true underdog that far, far surpasses any cool bird of prey when it comes to sheer, unimaginable endurance. Okay, let's dive into this impossible number, 13,560. Back in 2022, researchers strapped these tiny, lightweight satellite trackers to bar-tailed Godwits, and what they recorded absolutely stunned the world of biology. They proved, without a doubt, that this bird flew 13,560 kilometers nonstop from Alaska to Tasmania. To put that immense distance into perspective for you, that is farther than flying from New York City all the way to South Africa without taking a single break. No stopping to rest, no stopping to eat, no stopping to drink. They just launch into the sky, disappear across the Pacific Ocean, and keep going. This completely reframes our entire understanding of endurance. I mean, think about elite human athletes for a second. Marathon runners, mountaineers, ultra-endurance cyclists. They all require constant support. We need water stations, high-calorie gels, sleep, and, if things go wrong, we have rescue teams on standby. But the bar-tailed Godwit, this tiny creature completes an 8 to 11-day journey of continuous, non-stop flapping, powered entirely by its own stored body fat. Just imagine flapping your arms every single second for more than a week. It's literally incomprehensible. Which brings us to Section 1, a living aircraft redesign, how the Godwit prepares for infinite flight. So how on earth is this physically possible? Well, to survive this journey, the Godwit essentially modifies its own anatomy, kind of like a mechanic tweaking an airplane before a long-haul flight. First, in the weeks leading up to the migration, they become absolute eating machines. They consume so much food that they literally double their body weight, turning themselves into giant flying fuel tanks of stored fat. But a heavy plane can't fly, right? So step 2, they temporarily shrink their own digestive organs. They're not going to be eating over the open ocean, so they just drop that dead weight internally. Finally, step 3, to handle the unbelievable physical stress, they heavily enlarge their heart and their flight muscles for maximum engine efficiency. Nature literally redesigns them into a flying machine, and then, get this, once they finally land, their organs just grow back to normal. It is absolute science fiction happening right in our wetlands. Let's move on to Section 2, half asleep and navigating, the in-flight tech. Now, even with an enlarged heart and a body full of fuel, how do they avoid total exhaustion? I mean, how can any living creature sustain a week or more of continuous, aggressive physical exertion over the Pacific Ocean without just collapsing? The answer is unihemispheric sleep. Scientists believe these migratory birds utilize this incredible biological trick where they literally shut down one half of their brain to deeply rest, while the other half remains entirely awake and alert to maintain their flight mechanics. If this sounds familiar, it's actually because dolphins do something very similar to keep from drowning. Basically, the Godwit is taking a nap in mid-air, cruising at high altitudes over the ocean. But endurance and sleep? That's really only half the battle. How does a juvenile bird know exactly where to go across an open ocean? Think about the gravity of this for a second. Young Godwits, born only months earlier, will often migrate thousands of kilometers without any guidance from adult birds. They are navigating a featureless, terrifying abyss of open water where there are no roads, no landmarks, and no signs. And out there, a single navigational error doesn't just mean you get a little lost. It means certain death. It turns out these birds possess a hidden sensory world that we humans can't even imagine. They have a natural GPS system. They're reading the Earth's magnetic fields, tracking the position of the stars, and calculating sunset patterns. They can even see polarized light that is completely invisible to the human eye. Some researchers actually suspect that these birds have specialized proteins in their eyes that allow them to literally see the Earth's magnetic directions as physical lines in their vision. They aren't just birds. They are essentially flying supercomputers. What's truly fascinating is how long it took us to figure all of this out. In the ancient era, these birds and their ancestors had been traveling these invisible, globally connected routes for millennia, way before humans ever mapped the continents. Then, through the late 20th century, we had decades of unproven suspicion. Scientists suspected they were doing this, but they just didn't have the hard proof. It wasn't until 2022 that tiny, lightweight satellite trackers finally made this impossible journey measurable. Technology finally caught up to what nature had been perfecting for millions of years. And that brings us to Section 3, shrinking habitats and threats, the vulnerability of a master traveler. Despite their extreme, almost alien biological engineering, the Godwit has one critical vulnerability, and it's tied directly to the Earth far below their wings. They are considered living indicators of planetary health. Why does this matter to you and me? Well, scientists view migratory birds like the Godwit as the ultimate warning system for the Earth. Their epic journeys rely on unbelievably precise timing and very specific coastal mudflats and estuaries to rest, feed, and refuel. They are deeply, deeply connected to the health of multiple continents at once. Today, they face some massive interconnected threats: disappearing wetlands and estuaries, aggressive urban development on our coastlines, pollution seeping into the mudflats, and climate change disrupting their food availability. The Godwit uses its long beak to probe the mud for tiny marine creatures. Now, if just one of these vital ecosystems collapses, or if even a small climate shift delays the breeding of the insects they eat, entire finely tuned migration routes could completely fail. If these master travelers begin to fall from the sky, it's a glaring signal of much larger environmental problems that will inevitably impact humanity next. As we wrap up this explainer, I want to leave you with a rather humbling contrast. When we push human limits, we celebrate. We want fame, recognition, medals, and applause. We make whole documentaries about human endurance. But nature's reality? It's silent, invisible, global endurance. Every single year, millions of migratory birds perform physical feats that are vastly more extreme than many human-engineered machines. And they do it powered by wind, instinct, and determination, completely unnoticed by the world below. I want to end with this thought. Sometimes the most extraordinary creatures on Earth aren't the loudest or the biggest. They're the tiny travelers silently crossing the skies above us. The next time you're walking near a beach or a wetland and you see a small, unassuming bird probing the mud, remember what we talked about today. You might just be looking at the greatest endurance athlete on the planet. And tonight, as you look up into the dark sky, ask yourself, is there a tiny Godwit high above the Pacific right now, half asleep, reading the stars and silently flying toward a destination thousands of kilometers away?